Please note that Archimedes long before found that a circle has a certain relation. Whenever you expand the circle or make it bigger, this relationship doesn't differ. He found that the circumference, which is here, the circumference, if you can see, along with the diameter, there is a relationship. For this specific circle, it is found that the circumference over the diameter is pi. Okay. Also, here for this circle, whenever you expand the circumference over the diameter is pi also. If you expand the circumference, the diameter will expand as well. Okay, so it doesn't change the relationship that the circumference over the diameter is pi. Okay. So all of us, I think, studied math and know what pi is. In fact, if you check in your calculator what pi represents, you will find that pi is around, or let's say it is 3, 4, with some other digits with it. For example, let me check 3.14, 159. So it is not non-repeating and non-terminating decimal, so it is irrational number. However, what about 3.14? 3.14. Is this irrational number? It is rational number. Okay, rational number. What is pi? It is not 22 over 7. However, pi is approximated to 22 over 7. So 22 over 7 is a rational number and pi is irrational number. Okay, this is a brief note for you to take, and it is very important. It may come in the exam and you may face something like this. Okay, so let's discuss briefly what we have studied before. Positive integers, and we studied that the 0 and the negative integers are all integers. Okay, integers. Okay, we know that positive integers are natural numbers. Positive integers are natural numbers. So integers are positive integers, 0, and negative integers. Integers itself can go to the rational number set. Rational number set. The rational number sets, for example, we can say a fraction of integers 3 over 4, or non-repeating, repeating and terminating decimals. For example, if we say repeating 3.6565 bar, terminating we can say 3.75, or any integer -5, for example. These are examples of rational numbers. irrational numbers are those numbers that are not rational. Okay, they cannot be a fraction of integers. So you cannot say square root of 3 over 2 is rational number. It is irrational number because it is a fraction of non-integers. And so and also non-terminating or non-repeating decimal, 2.1567, or non-repeating decimals. It is non-terminating, non-repeating decimals. So as simple as that. Another example, square root of 7, for example, is a rational number. Pi is a rational number. So take these examples in consideration. We cannot say that integers can go to irrational numbers. They cannot go to irrational numbers. So please keep this in mind. It can go, yes, to the rational number set. However, to irrational numbers, it is incorrect. So these two, the rational numbers and irrational numbers, forms the what we call it the real numbers. Real numbers sets. Okay, so again, the real numbers are rational and irrational. It can be integers, it can be positive integers, 0, negative integers, can be square root of 3 over 2. Any number you face here, it is a real number. Okay, we discussed before the prime number and the composite number. We know what is the prime number. It is a number other than 1 that cannot that only can divide by itself and 1. The composite number, it has a factor, means another dividend. A factor, in fact, means a number divides the number evenly. Let's go through example. If we, for example, have list of numbers and we are to classify them. Let's say we have minus 0.2, 0, 0.3 repeating, 0.712177, we don't know the rest, by 6, 7, 41, 51. We have to classify them. Okay, let's say, what are the integers out of this example? The integers, we can say 0 and 6, 7, 41, 51. Those are the integers. 0, 6, 7, 41, and 51. What about the rational numbers? Rational numbers, for example, we can say it can accommodate integers. As we mentioned before, integers should go into the rational numbers. Okay, also the repeating and terminating decimals. So let's start from the lowest, minus 0.2, 0, terminating or repeating decimal 0.3333, and 6, 7, 41, 51. So what are the irrational numbers? Irrational numbers. The irrational numbers are not any one of these. Not any one of these numbers. Okay? What we can say, for example, 0.71217, we don't know the rest, by are the irrational numbers. Okay. What about the real numbers? Real numbers. Real numbers. We know real numbers is the rational and irrational numbers together. They combine. So I think you have to take all these values and write them down here. Okay. What about the prime number? Prime number is a number other than 1 that can only divide by itself and 1. So prime number other than 1 that can divide by itself and 1. 7, here is 7 and 41. 7 and 41. It can only divide by itself and 1. Composite number, we have, for example, 6 can divide by 2 or 3, and 51. 51, yes, 51 we can divide it by, let's say, if you divide it by 2, 51, if you divide it by 2 or 3, sorry, 3, you will here 1, so here 3, 2, 1, so 7, 17. So it is a composite number. It can be divided by 3. So be careful about the numbers. Try to divide as much as you can, if you don't have a calculator, of course, in the exam, to check if it is a composite or prime. Prime, you cannot divide it by any other number. Let's take another example. So the answer is, so look at the numbers you have. It is very important to have a first look and see how things go. You can get what are the integers here. Okay. Integers, for example, we can say 31, 51. Okay, those are the integers. Integers 31 and 51. What about the rational numbers? The rational numbers are, this is a rational number, and of course the integer, of course this is a rational number. Okay, this is a rational number. What else? This is also a rational number because it is terminating the integer and the repeating also. So those are the rational numbers. 5 over 7, 31, minus 2, 2.5, 4.230 or 3569101, 51, also 0.8. Let's make a bar here. What about the irrational number? Irrational numbers, we're having 5 over square root of 7. It cannot be irrational. What about the prime number or prime number? Let's say prime number. Do we have a prime number here? Yes, we are having 31. What about composite number? Do we have a composite number here? No. Yes, we have composite number. Composite number, we have 51. We said it before, 51, because 51, if you divide it by 3, it is 17. So 51 composite number. So real numbers, what are the real numbers? Real numbers simply are all the numbers are the real numbers. All of them here are real numbers. As simple as that.